This question resembles a puzzle. The substance here is non-algebraic in nature and naturally prods us into analysis by cases. Let's turn to the data statements separately first. Statement 1 tells us that the upper left and bottom center boxes of the table are each 11. Because of the non-repetition rule of 11s, that means that D2, the square that we are looking for, is the only other square that could be 11. It's the only square outside a row or column of the upper left and bottom center squares. So it could be 11. That's a case. But we can form another case in which it's not 11, because the digit 5 may occur twice in a row or column, and that's a lot of potential extra 5s. For example, the following case is possible. And in this case, we have a different possible value of D2. Therefore, we do not have sufficient information to answer the question definitively, and statement 1 is insufficient. Statement 2 tells us that a jumble of numbers multiplied together gives us 375. All the numbers at hand are prime, so let's do the prime factorization of 375. The principle here is that when you have multiplication or division involving an integer with largish absolute value, you should consider using prime factorization. The number here is clearly divisible by 5, so we can start there. This obtains 1 3 and 3 5s. So we are talking about the following shaded squares. Our objective here is to obtain cases that are both allowed but yield different answers to the question, indicating insufficiency. Our square of interest cannot be a 5, because whenever we try to put the 5s in the shaded squares, it would lead to 3 5s in a row or column with the shaded squares. It could easily be 11, since none of the numbers in its column or row are 11s. So that's one case. The remaining question is whether it could be a 3, forming another case. We don't know what shaded square the 3 is in, but regardless, putting a 3 in our square of interest would cause an illegal double in the row or column along which the already existing 3 is. Therefore, there is only one possible case. The square of interest must be an 11. We can therefore answer the question definitively. We have sufficient information. The correct answer is B.